What's up, math scholars? It's 9-1, 9-2, and 9-4 quiz review day, and we're on a shortened connection schedule, so we're just going to keep things rolling. Number 1, how would this graph be affected if the function were changed? Now, we are doing everything today in our handheld graphing calculator because the teachers have decided no Desmos on the quiz, but we'll have maybe a Desmos portion of our test. All right, so what you can do is you can graph the first graph, x squared plus 2, and you can take a peek at what it looks like. So take a mental note of what that looks like. It's my blue graph, since I have a colored calculator.
Oh, yeah.
Every student in the room should have their graphing calculator turned on and pulled out of their book bag.
That's just true.
Now if you want to, you can actually graph the second one in y2, x squared minus 4, and we're curious of what changed.
It'll move it downward.
Yeah, it all shifted downwards. So I would say shifted downwards.
How do you get those two lines again?
I put this into y1, I put this into y2. And I click graph.
You got a little.
Yep.
A very similar problem. Let's graph both y equals x squared plus 6, and let's graph y equals x squared plus 9 and see the differences. Some of you might already know what's going to happen, but let's graph them both. So there's my first one with the 6. There's my second one with the plus 9. So this is the one with the plus 6. This is the one with the plus 9. Where is it? It's kind of up there. It's shifted up. You're right. And you guys, you know you could have gotten this just by looking, and you wouldn't have even needed the graph. These are C values, and C values are y-intercepts. So basically, if the y-intercept is shifting from 6 to 9, it's an upward shift.
Woohoo! Oh, yeah.
So it's not really brain science. It's going to be a multiple choice question tomorrow from this question. The whole quiz is not multiple choice, but these first few questions are. All right.
How many of them are multiple choice?
I think maybe 4 or 5.
How many questions are? How many?
Find the vertex and axis of symmetry. So you know my first stop is always my table world and seeing if I can figure out the vertex from the table world. And if I cannot, then we'll be utilizing a formula, and I'll show you that formula. So let's go ahead and type in part A and see if we can find the vertex from the table world.
Table world.
Negative 4x squared, positive 16x, minus 1. So it's going to be an upside down looking graph because of the negative 4 up front. Oh, there it is. Oh gosh, the vertex is just slightly up off my screen. But you know what? We can scroll around the table and look at how the symmetry is developing. So I'm going to scroll downwards this way a little bit.
If only we had Desmos.
I think that's the point. I think they wanted to make you work for it a little bit more. Desmos is almost too easy. So, do you see the symmetry developing?
No.
We have 2 negative 1s here and here. We have 2 11s here and here. I can scroll up a little bit, but there's probably a negative 21 up here and a negative 21 down here. Who is your vertex?
15.
Yeah, right here. 215. 215 is the vertex.
Thanks, Brad.
That was super easy. Saw it right there on the table. If I can find it on the table, I'm not feeling the need to use formulas.
We still need to
Now, if I'm remembering right, we might have problems on part B finding, oh gosh, we are not done part A. Find the vertex and axis of symmetry. The axis of symmetry is just x equals 2. These numbers always match. All right, if I'm remembering right, we might not be able to find the vertex from the table in the second one, but we're going to try. Okay, we're going to try. It's going to be opening up. Can we see it? Yeah, and the vertex is down off my picture. Let's see if we can find it from the symmetry. Scrolling around a little bit. Oh, I was on the video. Hey people in the video, we found our symmetry developing, but we figured out that the symmetry is kind of centered smack dab between -2, -1 and -15, -15. So unfortunately, we're going to have to use a vertex formula to find it. Our vertex formula is x equals -b over 2a. And that vertex formula is going to be on the board. It's not something you're going to need to memorize. It's right up here where it says standard form of a parabola. If it's too small, I'll give it to you on a little slip of paper tomorrow. I've actually already copied it onto little slips of paper. In this case, A is 6, B is 18, and C is -3. So to do negative b, I would do negative 18. To do 2a, I would do 2 times 6. So I need to figure out what negative 18 divided by 12 is. Can you guys calculate that out for me?
How do we type this into the calculator?
Just type in negative 18 divided by 12.
But I'm talking about.
You don't do this on the graph. You're on your home screen and you're typing in negative 18 divided by 12.
Negative 1.5.
Negative 1.5. Okay. Now, what that just got us is the first half of the vertex, which means that also got us the axis of symmetry. However, I really need your thinking brains. If you know an x value and you need a y value, what could you do? What'd you say? Put a 1? I don't know that. Do what? No, not infinity. If you have an x and you need a y, you're just going to plug in that x value in for x, and then you're going to solve for y. Since this didn't show up on the table, you just type it in. It's very easy. So let's go ahead and type it in. You do need parentheses around that negative if you're squaring it.
I'm so confused. I'm confused.
Alright, so let me recap. The only reason we needed to use the fancy formula is we just couldn't find the vertex on the table because it was at a decimal location. So we used the vertex formula that will be provided to you. X equals negative b over 2a. B is 18. A is 6. We figured this out. 18 divided by 12 was negative 1.5. That was the x value. To figure out the y value, you just plug the x value in for x. You guys know that. You know how to plug things in and solve for y. Okay. Alright, these are all in vertex form. These are going to be a piece of cake. Vertex form is when you have a parenthesis and a squared. So what's the vertex?
X, or wait. Oh, wait.
7, negative 8.
Yeah, that's what I was saying.
If it's in parentheses, it's opposite of what you'd expect. So that's why I went with the positive 7 with the negative 8. Now, x equals 7 would be the axis of symmetry. Because this number here always matches this number here.
Yeah.
Is part B also in vertex form?
Yeah.
Sure is. What's the vertex?
2.
Negative 2, 7. Sure is. What's the axis of symmetry?
Negative 2.
Yep. Well, that was a breeze. Right now we're in vertex form. Just for fun, class, what's the vertex? 5, comma, negative 6. 5, comma, negative 6. But we want to convert it to standard form. How would we go about doing that? Ken?
Okay, then you actually have to split them up.
You do. So you have to split it up and write x minus 5 twice.
Yeah.
You're going to have a foiling party, and everyone's invited. Ken, what are we going to do?
Or, 2x, and then negative 10.
So he's going to distribute his 2 into the first group, and I agree with his plan. Now what?
They combine like 20.
No, not yet. We're not ready to combine like terms yet. At this point, you either foil or box. Do you guys like foil or box? Foil? Okay, if you like foil, you're going to do this matchup first. 2x squared. You're going to do this matchup next. Negative 10x. You're going to do this matchup next. Negative 10x. And you're going to end it with this matchup. Positive 50. Now that we're all foiled, now we can combine our like terms. Negative 20x and positive 44. All right, we've arrived at a graphing problem, and you're not going to have Desmo, so everybody head to their handheld TI-84. Let's get this in and make a table for ourselves. Hopefully we can find our vertex from the table. So x squared minus 8x plus 2. Table.
The calculator wasn't even on.
Your calculator turned itself off.
Or were you just not using it this whole time?
Stay focused. Aha, found it. I get excited when I find it. I always get nervous. I couldn't find it. Do you guys see where the vertex is located?
No, we can't see that far.
So you can see your symmetry developing. 11, 11, 2, 2, negative 5, negative 5, negative 10, negative 10, negative 13, negative 13. Bam, found it. 4, negative 14 is the absolute center of that symmetry that was developing. 4, negative 14. Now it's really up to you what coordinates you put on your table. Sometimes I look for maybe x and y intercepts, or people that have zeros with them. See this 0, 2? I really like that 0, 2, because that's an intercept, so I would include that.
How do you go to the table?
What? How do you go to the table?
Yeah.
Second table.
First table.
Second graph. Are there any other numbers on here you think I should put on my table that look really important?
8 and 2.
8, 2? Sure. She wants 8, 2. Is 8, 2 even a point?
Yeah.
Okay. Okay. 8, comma 2 is a point. 8, 2. Okay, Melanie wants 8, 2. I like the idea of 8, 2. Let's graph this. So 0, 2 is here. 8, 2 is here. 4, negative 14 would be down off the picture. So it's kind of going to be opening up like this. Opens up. What? The axis of symmetry is x equals 4. Because the vertex is 4, negative 14. Now, to be honest with you, the intercepts did not show up on the table. So I'm thinking they're just at decimal locations that we're going to have to estimate. Where would you estimate this is crossing the x-axis at?
Round it up.
I'm thinking like 0.1 and maybe like 6.9. It's just slightly below 7 from what I'm seeing. If it was exactly at 7, 7 comma 0 would have been on our table. 7 comma 0 wasn't on our table. 7, negative 5 is on the table. The y-intercept was on our table, 0, 2. Is the vertex acting as a minimum or a maximum point? It's at the bottom of a bowl, so a minimum point. And then the domain is negative infinity to infinity, with range being negative 14 to infinity, because that's the lowest it can go. It's negative 14. It's the minimum point.
How do we find the minimum?
Hey people, in the video we end up changing our answer for x-intercept. I had a student, he was like, that's not touching it. 6.9 is closer to 7.9. He was right. Well, let's keep moving along. We don't want to run out of time.
Are you kidding me?
Why does it say 7?
Wait, did I just write
Why
on the wrong one?
Who's down?
I don't know. I think maybe my number 7 got lost. Let me scroll. Found it.
You're on video.
All right, let's graph this in. Put it in your graphing calculator. I'm just doing it in my handheld, so it's not going to appear on the smart board.
Vertex is...
I'm going to head to my table and see if I can find my vertex or not. If not, guess what? We'll have to use that formula. I'm scrolling around looking. I'll be honest, I'm not finding it.
Me either.
So we'll probably have to use our formula. But it'll be good. We can practice our vertex formula one last time. It's negative b over 2a. So a is 2, b is negative 3, and c is negative 3. So it would be a positive 3 over 2 times 2. So 3/4, or 0.75. Now if you have the x coordinate of the vertex, how do you find the y coordinate of the vertex? Plug it in. So it's 2 times 0.75 squared minus 3 times 0.75 minus 3. So just using that formula.
That's gonna be the hardest.
Yeah, so I'll be honest, every time I put it in my table world, I just cross my fingers saying, please let me find that vertex, because if not, I'm doing it by hand. Okay, what you're seeing right here is me putting my x value in, my 3/4, which is 0.75, in for x, here and here. The only way to get a y value is to plug in an x value. And when I plug it in, I get negative 4.125. I'll just go with negative 4.1. I really only need a couple other points off of my table to fill out my table. I'm going to go with 0, negative 3, because it's like an intercept. And how about 2, negative 1? I just grabbed 2 points off my table randomly. So here's one of the points I've gotten Here's one of the points I've gotten. Here's one of the points I've gotten. Ooh, that can't be right. I must have graphed one of these wrong. The table, or the picture kind of looks like this. Well, maybe that is right. I'm terrible at my drawings, but it kind of does look like that. It would open up. It'd have an axis of symmetry of 0.75. Can we please keep the noise to a minimum? We're on a video, and we're trying to get done before the bell rings. We're not doing good. At this point, I think we're going to be rushing, and maybe not finishing. Intercepts, we're just estimating again. How about negative 0.8 and 2.1? The y-intercept I did find on my table, 0, -3. It has a minimum because it opens up. Your domain's negative infinity to infinity, and your range is negative 4.1 to infinity. Because it never goes below that minimum point, which is the vertex. We're gonna keep on chugging along. Let's go ahead and graph this one in the calculator. You should already know the vertex, everybody, because it's in vertex form. What's the vertex? 1, 4. Just a positive 1, positive 4. But I'll get a couple other coordinates from my table in my calculator. 1, 4. We've already got the vertex. It's opening down because that negative out front. I'll just grab another couple coordinates from my table. How about 0, 2 and 2, 2? Just grab those from my table so I can graph this.
Is it 2?
Is what 2?
Like 0, 2.
Yeah, 0, 2 showed up on my table. Sure did. It opens down. The axis of symmetry would be x equals 1, because that's the x coordinate of the vertex. This has a maximum because it opens down and it has a mountain peak. Oh, these x-intercepts are killing us today. We're just going to have to estimate them again. What do you guys think? 2.5 maybe? And maybe negative 0.2?
No.
The y-intercept is 0, 2. That's where it touches the y-axis. Domain, negative infinity to infinity. And range, negative infinity to 3. Yeah. Hey, this is going to be a long video, so we thought we'd throw in a keyword to see who's watching it. The keyword is coronavirus. Hope nobody has it yet. Nobody in Ohio has been reported having it yet. However, Ohio has not received their test kits either, so Ohio doesn't have a way to test for it yet.
Ohio did have it at a college.
Let's go.
All right, here we go. Last two. It says, let's write it in factored form and then find the x-intercepts, which are the solutions. I think there's still some people that are a bit confused that x-intercepts and solutions are actually the same thing. So you guys know how to factor, right? We've been doing that for weeks.
Yeah, it has to add.
It has to multiply to negative 63, but add up to 2. 63 is a big number to experiment with.
60?
Wait, does it have to
I
add
figured it out.
Doesn't it have to add negative?
Yeah, add a negative 2. Nick got it. Good, make it a negative 9 and make it a positive 7. Now to find the solutions, you set that x minus 9 equals 0. And you set that x plus 7 equals 0. So 9 is an answer, and negative 7 is an answer. So you factor it, you solve it. Factor solve. We did that in the chapter 8 test, so it's just like making another appearance. Nothing's different. All right, same thing, factor solve. So we need to multiply to the 35, but add up to the negative 12. Can you think of it? Garrett thought of it. Make them both negative, and it's negative 5, and it's negative 7. And so what does that make the solutions?
Positive 5.
Yeah, so the solutions are always like opposite what you pick for factored form. So the solutions are positive 5 and positive 7. Okay. Hey people at home, thanks for watching the 20-minute video, longer than most, but we powered through and we made it with 8 minutes to spare. Look at us. I know I was nervous.